multi-step equations and inequalities. Next, we will add a constant outside the absolute value expression and a constant in front of the x within the expression. The key to solving multi-step equations and inequalities is to reduce them to the form of the absolute value of x minus c is equal to d, and then proceed as shown in the earlier topics. So here you'll notice we added a 1, a constant outside the absolute values, and we also added a constant in front of the x within the absolute value. Let's continue on. For example, the solution for the above inequality is we take away 1 from both sides, so I'm going to take away 1 here, and that's going to leave me with the absolute value of 2x minus 4 is less than or equal to 2. Next, I'm going to factor out the 2 right here, and that's going to leave me with x minus 2, the absolute 2 times the absolute value of x minus 2 is less than or equal to 2. Dividing both sides by 2, kind of squeeze that in there like that. That's going to leave me with the absolute value of x minus 2 is less than or equal to 1. Next, we set up our two cases, and we see that x can be greater than or equal to 1 or less than or equal to 3. Number of solutions. Once a multi-step equation is arranged to be in the following form when a and b are constants, so we have the absolute value of x minus a is equal to b. Notice we are talking about equations. In this case, we're not talking about inequalities. We're talking specifically about equations. That's important to note. So we have it set up like this. The value of b will determine how many solutions can be found for the equation. There's three cases. In case number 1, if b is less than 0, meaning that it's negative, there are no solutions. That makes sense because absolute values are never negative. So if b is negative, there's going to be no solution. Case number 2, if b is equal to 0, there's going to be exactly one solution. The third case, if b is positive, greater than 0, there are going to be two solutions. If a multi-step equation cannot be reduced to the simplest form, then errors can be made as shown on the next slide. The constant that an absolute value equation is equal to has to be 0 or a positive number. If we have the absolute value of x plus 7 is equal to negative 15, that will not have solutions because there isn't a number in a real number system that I could put in for x that will give me negative 15 for an answer. Absolute values are never negative. By definition, they can't equal a negative number. In the second case right here, we have the absolute value of x plus 7 is equal to 0. That has one solution. Actually, that one solution is negative 7. When x is equal to negative 7, negative 7 plus 7 is 0. The absolute value of 0 is 0, and that's my one solution. But if I have 7 minus the absolute value of x minus 5 is equal to negative 22, that will have solutions because once the absolute value expression is isolated, it is equal to a positive value. So at first glance, you might say, hey, there's no solution here. This is equal to a negative number. But watch what happens when we perform some algebra. I start by subtracting 7 from both sides, and that leaves me with negative, the absolute value of x minus 5 is equal to negative 29. I divide both sides by negative 1, and my final expression is going to be the absolute value of x minus 5 is equal to a positive 29. That will have solutions. Example number 1. Solve the following. 1 plus the absolute value of 2x minus 4 is equal to 3. Notice we have an equal sign. We're dealing with an equation here. So the steps will go as follows. I start by subtracting 1 from both sides, and that is going to leave me with the absolute value of 2x minus 4 is equal to 2. I factor out my 2, and I'm going to have 2 times the absolute value of x minus 2 is equal to 2. Divide both sides by 2, and we have the absolute value of x minus 2 is equal to 1. Next, I set up my two cases. X minus 2 is equal to negative 1, and x minus 2 is equal to positive 1, which leaves me with two answers. X is equal to 1, x is equal to 3. So my solution set is x is equal to 3, 1, and 3. I'm going to test one of these just to make sure. So let's take 1 plus the absolute value of 2 times 1 minus 4. Let's see if that's equal to 3. So I have 1 plus the absolute value of 2 minus 4, because 1 times 2 is 2. Does that equal 3? I have 1 plus, now this is negative 2. The absolute value of negative 2 is positive 2. And 1 plus 2 is equal to 3. So it checks out. That works. I'm going to leave this up to you. What is 1 plus the absolute value of 2 times 3 minus 4? Will that equal 3? Find out on your own.